This is Getacho from EthioGate YouTube channel, and today I have a new video for you about LG LED TV power sequence, and I just prepared this block diagram, and I'm trying to explain the power sequence for LG LED TV. Okay, to begin today's tutorial, as you see we have two boards, which is the power board and the main board. And as the power board, we have a SMPS, which is a primary section of the power supply, and the backlight driver circuit, standby IC, and multi-circuit, which is the multi-IC. And at the main board, we have a MICOM IC, SOC chips, which is system on chips, and the DC to DC converter IC, which is the regulator. We have the audio section, and at the screen parts, we have the TCON board, and I'll try to explain how these two boards are working together. Okay, when we provide an input voltage, depends on the country, the voltage that we provide for the power supply is different. Which is, in our cases, it is 220 voltage AC. In some countries, they use 150 AC voltage. Whatever we have an AC voltage, whenever we provide these input signals or this input voltage for the power supply, the first thing that we need to have is a standby output voltage, that is 3.5 voltage. So our first testing point will be, which is the number one, we have STB standby voltage, that is 3.5 DC voltage, okay? So when the MICOM IC receives this standby voltage, the MICOM IC sends directly this voltage to the IR, right? So the MICOM IC sends this standby voltage, which is 3.5 voltage DC. So when the IR receives this voltage, our LED at the IR point will be bright. So we have a key, or we will use the remotes to turn on the products or to turn on the television. When we press the power button or when we press the power key from the TV side, we will have return voltage, which is power on voltage. So we will have power on voltage, that is 3.2 DC voltage. So after we press the power key on the remote side, we will have 3.2 voltage, which is the power on voltage from the IR side, and it goes to the MICOM IC. Then the MICOM IC sends this power on voltage to the power boards, which is 3.2 voltages. So this is the second point that we have. When this 3.2 voltage will reach to the power boards, then this 3.2 voltage goes to some circuits. It has around 30 to 50 components, and I'm not explaining these parts because today we are discussing about the block sides. At this point, we have a lot of components, around 30 to 50 components. So after these parts, we'll have VCC voltage, which is 60 voltage. So this 60 voltage directly goes to the multi-IC. When the multi-IC receives the VCC voltage, which is the 60 voltage DC, then the multi-IC then runs, and we will have two output voltage. One, which is plus 12 voltage DC. The second is plus 24 voltage DC, right? So let me explain shortly. When we apply this AC voltage, then our first starting point will be standby IC will turn on, then standby voltage 3.5 voltage which directly goes to the MICOM IC, then the MICOM IC sends standby voltage to the IR. Then when we press the power key at the IR points or from the remote sides, we will have 3.2 voltage, which is the power on voltage. Then this power on voltage directly goes to the MICOM IC, then the MICOM IC sends this 3.2 voltage to the power boards. Then at the power boards we have some components. After that components, we will have output from this component, these parts. After this circuit, we will have output from this circuit, which is around plus 60 voltage, which is a VCC. Then this voltage will directly send us to the multi-IC. This is a VCC for the multi-IC, and the multi-IC will run at this time and we will have two output voltage, which is, that's why we are calling multi, and we will have output which is 12 voltage plus 12 voltage and plus 24 voltage output. Then this plus 24 voltage will directly goes to the audio section, right? So it goes to directly the audio section. 12 voltage will directly goes to the T-con. Once directly goes to the T-con, the other is directly goes to the DC to DC AC. As you see, we have plus 12 voltage, and this plus 12 voltage directly goes to at the T-con borders, and this plus 12 voltage directly goes to at the DC to DC AC. Then the DC to DC AC receive plus 12 voltage. The T-con borders receive plus 12 voltage. When the DC to DC AC receive this plus 12 voltage, and this DC to DC AC converts from 12 voltage to 3.3 voltage, which is, it is a regulator IC, right? So we will have from DC to DC IC, we will have 3.3 DC voltage from the DC to DC IC. This 12 voltage directly goes to the DC to DC, then the DC to DC converts from 12 voltage to 3.3 voltage, right? When the SOC chips or the system on chips receive this 3.3 voltage, then the system on chips, the SOC chips will give us a drive on signal output, right? So we will have output from these points, and we will have a drive on signal, right? Drive on signal, which is 3.5 voltage, right? Where the SOC chips receive 3.3 voltage from the DC to DC IC, then SOC chips will give us drive on signal to the driver backlight circuit, right? This is 3.5 voltage drive on signal. When the backlight driver circuit receives the power on signal, then the backlight driver circuit will give us output for the backlight, right? And we will have output, and we will have output for the backlight, right? So the SOC chips will give us drive on signal. This signal help us to turn on the backlight driver circuit. When the backlight driver circuit receive the drive on signal, which is a 3.5 voltage, then the backlight driver circuit give us output voltage for the backlight. By the way, our backlight voltage for LED model, which is from 90 to 240 voltage, right? And we have one additional point, that's a testing point, which is the error voltage, right? So this error voltage can be determined depending on the functionality of the backlight. So we have error voltage from the backlight pointers, and connects to the mainboard, right? So this point is error voltage. Error voltage. So this error voltage can be either zero or it will be 5 voltage, right? So what do you mean by 0 voltage, or what do you mean by 5 voltage? This voltage is just for checking the backlight, right? Whenever you are trying to check the backlight is functional or not, this is the only points you can understand, or you can determine the backlight is functional or the backlight is defective. So whenever we are measuring the voltage at these points, at the error voltage points, and let's say we are measuring 0 voltage at this point, right? So 0 voltage is the backlight will be normal. The backlight is normal. The backlight is functional. Or if we measure 5 voltage at this point, the backlight is defective, right? So this is the point. So how the SOC chips determine the brightness? Let's say we are measuring at this point, and our meter showing us 0 voltage. This means the backlight is normal. And when we are measuring 5 voltage at this point, our meter showing us 5 voltage. This means the backlight is defective, right? So the normal working situation will be the SOC chips should determine the backlight brightness, right? Or the brightness of the television. We have two controlling mechanism to determine or to control the brightness of the television. We will have connection, error voltage will directly goes to the SOC chips, right? when the SOC chips receive this voltage, either 0 or either 5, we will have some control mechanism, right? So let's let's connect our error voltage points to the SOC chips, and let's say we are measuring 0 voltage at these points, and we already know that the backlight will be normal when we measure 0 voltage. So this 0 voltage directly goes to the SOC chips. Then when the SOC chips check 0 voltage at these points, then the SOC chips will give us two outputs, right? One PWM 1 and so when the SOC chips receive 0 voltage, then this 0 voltage directly goes to the SOC chips, and the SOC chips sends two signals, which is the PWM signal 1 and the PWM signal 2. Two signals is just control the brightness of the television. One is control the brightness of the television, the other is controlled by the environment, right? So what if we have 5 voltage at this point? So when we have 5 voltage, this 5 voltage directly goes to the SOC chips, and the SOC chips will not send any signals to control the brightness because we don't have any lights from the screen side, right? So when we have 5 voltage at this point, we don't have any output from the SOC chips. There is no signal that is sent to the backlight driver circuit. But when we have 0 voltage at this point, this 0 voltage directly goes to the SOC chips, and the SOC chips will give us two controlling mechanisms, the PWM1 and the PWM2, right? This one controls the brightness of the television according to the picture of the television, and this one is control the brightness of the television based on the environment, right? So this is all about today's training. By the way, this is EthioGauge YouTube channel, and this is Getachew from EthioGauge YouTube channel. And make sure you are subscribed my YouTube channel in order to have this kind of training. Thank you for watching. Bye bye.